Hello everyone, welcome to our demo for Sprint 5. We are the team Rapdev. First, I am going to go through what all we had completed in the last demo. We have successfully built the pipeline script for multiple services using Jenkins and Docker. We deployed the Datadog agent on the localhost to push the infrastructure metrics and traces to Datadog APM. We had deployed the application using Kubernetes, but we are facing some issues which will be explained in the later slides. In this sprint, we have achieved the following. We successfully automated the Jenkins server creation using Terraform, successfully integrated the Jenkins and AWS to Datadog, and researched on how to automate the integrations between Datadog and other platforms. We found a plugin to convert Datadog monitors and dashboards exported as JSON into Terraform. We worked on deploying the application on both EKS and EC2 instances. We successfully added test cases for the application using Datadog synthetic monitoring.
So Docker Compose for deployment. So initially we were going to use EKS for deployment, but since we were working on multiple microservices, we were facing some networking issues between multiple microservices while deploying the application. So we discussed this with our mentors and they suggested us to use Docker Compose instead. So we'll see more about Docker Compose now. So Docker Compose is a tool to define and run multi-container Docker applications. It is basically a three-step process. First is to define the app's environment with a Docker file so that it can be reproduced anywhere. Then we define the services in Docker Compose YAML so they can be run together in an isolated environment. And then we run the Docker Compose up, which basically starts and runs the entire app. You can also alternatively run Docker Compose up using the Docker Compose binary. Now let's have a look at the Docker Compose YAML file. So this is the Docker Compose YAML file. Here we define a network. So here we have named it as micro network. We have 4 services: user, product, order, and front end. So for each of these services, we have defined the image over here, the port number, and the related configurations. Similarly, we have done the same thing for the product microservice, for the order microservice, and for the front-end app. Okay, so now using this Docker Compose, we have deployed the app on AWS EC2 instance, and this is the screenshot of it.
Hi, everyone. In this part of the presentation, I'm going to demo how we managed to use Terraform to initialize AWS EC2 instance with a pre-installed Jenkins running on port 88. So a little bit background story about what Terraform is. Terraform is an infrastructure as code IAC tool that allows you to build, change, and version the cloud infrastructure safely and efficiently. For example, if in a project we need to initialize 30 EC2 instances, that each instance will be running a different Python microservice. And instead of manually initializing all the EC2 instances one by one, we can write the script to do so, which will save a lot of time for the developers. So now we're going to demo how we managed to use a Terraform to initialize AWS EC2 instance that successfully pre-installed the Jenkins and running the Jenkins automatically. This is how our script look like. At these parts, it's going to initializing what kind of cloud provider you're using, and in our case, we're using the AWS, and the region we want to deploy the instance. It's at the US East 2. We also have the configuration for the security group, which we exposed these 4 ports that will be running different applications, and this part is where we use the remote execution to pre-install the Jenkins once the instance is created, and by doing so, it will allow the latest created instance to have a Jenkins running on a specific port. As you can see, at this current directory, we have the main.tf file ready. And the first step we're going to do to use Terraform is to use Terraform init initialization, what it does, it's kind of pre-compile the script that we have currently to make sure that there's no syntax error and such things. And then once the initialization part is successful, what we can do is we can do a Terraform apply, which was going to apply the content in the script to create this new instance. And here it's just going to display like all the configuration about this new instance and so on. So if we enter yes here, it's going to start initializing this instance, and this may take about 3 minutes. I see. As you can see, the whole process of creating this new instance took 3 minutes and 2 seconds. Now let's go to the AWS control panel and copy this instance IP address that we just created. And if we put it in the browser with the port 8080, you'll see the Jenkins is now successfully installed and running at this new instance port 8080, and the end user can start to start creating their Jenkins pipelines from here.
Just like Terraform was used to initialize the Jenkins instance with its dependencies on Amazon EC2 instance, we also use Terraform to create the infrastructure for deployment. As mentioned before, we are using Docker Compose for deployment and need to set up this infrastructure using Terraform. The steps for provisioning the EC2 instance remain the same as that for Jenkins. The only addition would be to add the commands for downloading Docker and Docker Compose. The next step would be to run the Docker Compose YAML file.
Hi everyone, I will be walking you through the updates made in the monitoring using Datadog. For this sprint, we successfully integrated Datadog with Jenkins, AWS, and GitHub. Besides this, we also created a custom dashboard for our project, which we are still improving. Also, the major learning in this sprint was we could avoid a lot of manual work. So firstly, there is a plugin called the Datadog to Terraform Converter, which helps for this to work, we first need to export the dashboard in JSON format, and then this plugin converts the JSON into Terraform. The second one is Terraformer, which helps us to export the monitors or alerts directly from the dashboard. Currently, we have done the integrations manually and will be converting them into Terraform. Let me take you to the dashboard that we have created. After integration with different platforms, we get to see these charts. The first one, GitHub, where we get to see the most recent commits. The second chart is about Jenkins, where we get to see the Jenkins build events, the status of the Jenkins node, the successful versus the failed jobs, the completed jobs over the past 1 hour. In web application, we get to see the service map. Upon clicking the related traces, we get to see the detailed logs about the service. And here, upon clicking each request, we get to see the flame graph. In the infrastructure, we get to see the active EC2 instances, the CPU utilization by the instance type, the active EC2 instances by the instance type, the reads by the instance, and the writes by the instance type. In the Docker we get to see the number of running containers, the containers by images, and so on. So as you see, we have also added the monitors onto the dashboard. So some of them are manually configured monitors, and some of them are synthetic tests. And these synthetic tests run every 1 hour on 16 AWS location on Chrome, Firefox, and Edge.
So this is the burn down chart for this sprint. As you can see, this graph has a straight line initially and then a slope. This is because all our tasks were interconnected with each other, and they were mostly, all of the tasks were mostly dependent on the deployment. And since we fixed that around the end of the sprint, that's why you can see the slope.